Hi everybody, welcome to this video which is going to show you a method to use the Snell's law of refraction. So the refraction is this phenomenon where a ray is bending when it crosses a boundary between two medium. And the law is N1, the index of refraction of the first medium, times sinus I1, equal to N2, the index of refraction of the second medium, times sinus I2. This law is very easy to be known by heart, but not always easy to apply. When we have to do an exercise about Snell's law, we have always to do a good diagram. Here, a laser ray is crossing a boundary between air and water. Your diagram has to be precise, and we have to trace the normal, which is the line perpendicular to the boundary. We trace the angles, I1 for the first medium, I2 for the second medium, and the angles are always related to the normal. We have got the index of the two mediums, N air and N water, so we substitute in the Snell law the two index of refraction, N air and N water. So we have to take care of what is the first medium and what is the second medium. In this formula, you don't have to learn this formula by heart. It depends on the situation. For example, a laser ray which comes from water and is crossing the boundary to go into the air. We have got exactly the same Snell's law equation, but now N1 is not N air, it's N water, and N2 is N air. So take care to not learn by heart this equation. It depends on the situation, always. So you have to trace a good diagram. Another example, we have optic fiber with the core and the cladding. The index of refraction of the core is a little different from one of the cladding. We have got the angle I1 related to the normal, I2, medium 1, medium 2, and we are writing the Snell's law. We substitute N1 and N2. N1 is the index of refraction of the core, of the fiber, of the optic fiber, and N2 is the index of refraction of the cladding. So now we have got an equation, how to solve it. So now, how to solve the equation. For example, an exercise, we have an optic fiber and we want to find the critical angle to have an angle of refraction of 90 degrees. So we are looking for the critical angle. We are looking for I1 to get I2 equal to 90 degrees. If I1 is higher than the critical angle, it will occur a total internal reflection. So, how to solve the equation? Here we have an angle I1 and an angle I2, and when it's the critical angle, we have got an angle I2 equal to 90 degrees. So we are writing the Snell's law. Medium 1 is the core, medium 2 is the cladding. What do we know? We know NC, we know NG. Do we know I2? Yes, we want to find the critical angle, so we know I2, it's 90 degrees. Do we know I1? No, it's an unknown. We are looking for this value. So we have a mathematical equation, 3 known parameters, we can solve it. So, the equation, we have got a formula, we'll rearrange it to get what we are looking for. We have got a formula for what we are looking for. We substitute, we replace only now with the values of the other parameters, and we get the result. For this optic fiber, with parameters NG and NC, if I1 is greater than 76.8 degrees, total internal reflection will occur. A last example. This time we have got a laser ray which comes from water and is crossing a boundary to go in the air. We have to find the angle of refraction. We have got the index. Medium 2 is the air, medium 1 is water. The I1 angle, take care, is not 60 degrees but 30, because we have to give the angle compared related to the normal. I2 is the unknown, we are looking for it. So we are writing the Snell's law. We substitute. 1 is water, 2 is the air. So we have got an equation. We are solving now the equation. N water times sinus I1 equal to N air times sinus I2. We are looking I2. So we put N air in the other side of the equation. In fact, N air is equal to 1. So sinus I2 is this value. And we have just to get the arc sinus of this value, which is 41.7 degrees. So take care in your exercise to get the angle related to the normal, always. So, to solve an exercise with Snell's law, don't forget to always trace a good diagram with the angle always related to the normal. So you have to trace on your diagram the normal, and you have just to write the Snell's law and to apply it with the situation. So the Snell's law is easy to learn, but to apply it you have to do a good diagram and to substitute the index of refraction for each medium. After that, it's just mathematics. It's not physics. So I hope that this video will help you. And if you are interested in French, this broadcast is for physics and also for drafts. And I hope you will enjoy it. See you.